In this problem, it's asking us to calculate a p-value exactly using exact binomial calculations. So here we flipped a coin, we got 55 heads out of 100 trials, and we want to test whether or not the coin is fair or it's biased towards heads. So that means we want to test h naught p equal to 0.5 versus ha p greater than 0.5. Okay, so that's the hypothesis we want to test. And so we just want to do p binom. So we want the probability of getting as or more extreme data than was actually observed. So that would be 55 or higher. But then when we do lower.tail equals false, it does strictly greater than. So we got to tell it 54, so it starts counting at 55. Then we want size equal to 100 and prob equal to 0.5 and lower.tail equals false. Okay, so we get 0.18, and I'm just going to copy the whole thing because I don't want to worry about how many decimal places to input. And I'm going to put in 0, and I'm not sure why it's marking that as wrong, because clearly we would fail to reject for the 0. And if you look, it actually says the answer to 2 is 0. I think there's just a JavaScript error in the grading there, especially because it says the correct answer is 0 there. So I'll correct that JavaScript error, but if you happen to be getting it as well. Now, let me just show how you could do the same calculation or a similar calculation using the normal approximation, right? So we know for the normal approximation that the sample proportion p hat is normally distributed with a mean of p and a variance of p times 1 minus p over n. So here, if I want to do this with a normal approximation instead of the binomial approximation, I would do p norm, my sample proportion 0.55, my mean is 0.5 under the null hypothesis, and my standard deviation is square root p, which is 0.5, times 1 minus p, which is also 0.5, divided by n, which is 100. And then I want lower.tail equals false. Okay, so the approximation is not bad. It's 0.16 approximating 0.18, so that's not terrible. But at any rate, that's how you're getting the approximate calculation. The one on the top is the exact binomial calculation. Okay, so that problem's not so bad. I think we have a similar quiz problem where we asked to do a binomial calculation, but with a lot fewer, and n being much smaller, so that you would never even consider doing the normal approximation.